Right, good afternoon. I'm going to be looking today at, looking at continuing the work I was doing on the ARM disassembler. So this is a project to make a debugger for RISC OS using the DARM disassembler as the basis, although we could swap it out for something else in the future if we wanted. So far we got a whole bunch of the commands, and we're sort of at the point where things are actually working reasonably well, I think. I have, in the time that we were since the last live coding, I've been creating a project, so I just wanted to check how this worked and make sure it was actually how I was expecting it to be. So in GitHub you can get projects which are actually related to your user, and they can span multiple different repositories. This time we're only using one, but I've started populating this with some details of things that are missing. So we've got a bunch of problems here, so some bugs for error returns, and I noticed that the command syntax was a bit untidy. ARC62 debugging is on my radar because it's also in the RISC OS Pyromaniac source as well. Debugger Plus is Darren Salt's debugger, which has a bunch of extensions for how the output is formatted and a bunch of other things. Instruction comments on constant values. Now this is something that's obviously very common on the standard classic debugger, because it has comments like this is unsafe in certain operations and whatever. I'm not sure that I want to do those sorts of things. That wasn't particularly something I cared too much about, but it can be useful. More significantly though, this is the comment, the issue here is about constant values. So on the Pyromaniac disassembler, we've got comments about what the constants mean. So if it says hex 4000, that it'll tell us that that is such and such a value in decimal and that it's bit 18 or something. I don't think it's 18, I think it's 14. Something around there anyway. And what's the next one? We've got CI builds of the code, so being able to get things to automatically build through the build system on the RISC OS build server. Having a disassembly of the floating point instructions could be useful. I think that would be quite necessary. The debug operations, I'm not sure I really want to do those because I've never found them to be useful. So that's things like star debug, which just gives you a new prompt that you can start doing things. You can set breakpoints, you can do continue and things like that. I don't think it's especially useful, but it's something we could do potentially. Star memory A was something that Andrew had requested when I'd gone, oh, I don't think we need to do that. Maybe. I've got it on the list anyway. There's a ticket here for disassembly operands are not very friendly. So some of them report really odd things. So it says, so BL space hash and then an address, which is not exactly great. It's not what we're expecting. So yeah, I'd like to tidy that up. And debugger disassemble arc is the way that we'll actually introduce 64-bit and the like. What else we got? Oh, and then of course comparing the output using the Pyromaniac debugger tests. So that's a quite important one. So seeing how different they are will also influence which things we need to fix and what's broken or what have you. Because that's why we do tests. So those are the things that I've got in my list. I've said today I'm going to attempt to do the CI testing. So this one here. So let's move that over to in progress. and let's have a look at what it says. I may have added some notes in it. We should really be building this with the CI every time we merge so that we know that it's working. It wouldn't be too hard to add a simple build that checked that things were working. That is quite true. It shouldn't be that hard. So that's what we're going to try and do. I'll assign myself. Not that there's anybody else on this project, but let's do it properly. Okay. I could even start doing things like milestones and mark things so that I've actually got something that's prepared for release and some that aren't for release and things. I mean, it'll be fine anyway, but we'll see how this goes. Okay then. So let's have a look at this. Oh, so I've also labeled these with different tags. So some things are bugs, some things are enhancements, and some things are for parity. So bug obviously means something's gone wrong, or is incorrect in the general scheme of things. An enhancement is something that I want to improve above the original version, but it's also, I've got it labeled as parity here. So ARC64 debugging, actually it should be just disassembly, I suppose, that's not debugging. I'll change that. In fact, I'll change that now. Let me do that. Edit the title and make it disassembly, because I don't really want to be considering debugging right now. There we go. ARC64 disassembly. Thank you very much. So yeah, it's a parity feature because RISC OS Pyromaniac already supports it. So I'll be bringing it to parity of that, but I'll be enhancing it over the top of the classic version. I'm not sure these are particularly sensible ones, but I've labelled them anyway. I thought I'd have a play with it and see what I could do. And so now we've also got the enhancement, and this is a testing things because in theory it will test everything as we merge things. So let us go back to DOM here. This is probably pretty much where we left off, I think. And last time I was working on it, I decided that I was going to try doing it with the code at the top and the editor at the bottom, the compiler at the bottom. I think I'll do that again because I think that worked better. So I'll move that one to the top and move that to the bottom. I might need a little bit more room in the editor, I think. Let's spin that down. Hello, kittens. And then spin this one down as well. There we go. I've been using Windows recently, and it has a nice feature that if you put them together, it actually moves them both at once. I'm actually liking a feature of Windows. That's novel. Okay, what was I doing? I was doing, right, so I'm doing CI. Yeah, Alan said that he thinks it looks better with them along the top and bottom. I think it's a lot easier to read, so I think this is going to be a good thing. Okay, so one of the things we need to do to make this to run CI is we need to create some special files. So these are created inside the .github directory. Fortunately, I have a magic command to create these for me. If I do create CI, it will go and create some things. Didn't know the name. Let me just... I'm a little surprised it didn't... Oh, because it doesn't... Right, so this is an interesting one because it creates it based on whatever is in the makefile. And the makefile isn't actually a RISC OS makefile, so it didn't recognize it. I think that's a bug. I think I want to make RISC OS projects error if you haven't given it a name. So I'll just delete the files that's created. There. Yeah, delete that. And then I'll do this, but I'll give it a name because this is called DOM. Or is it Debugger? I'll call it DOM. That's what I've been calling it up till now. Oh, and that's a bug because that definitely didn't work. All right, well, we can fix that. Oh, actually, yeah, all right, I'll fix that later, but let's just do it this way. I'll do it in the RISC OS directory. No makefile recognized that. Well, it's really good, this, isn't it? All right. We'll just do the creating it, and we'll fix up the bits where it's gone and lost the names. That's going to be interesting. Okay, so that's created this file, and it's so that I can automatically build things using build RISC OS online. It's configured so that every time we do a push, it will build the branches, and every time we push a tag that starts with a V, we will do some builds as well. If you want to do it on pull request transitions, you can also do it there as well with that and commenting that. So what we do is we build it on Ubuntu latest, just because that's the easiest thing to do for me. We've got a couple of variables that we'll pull out, and we use a special checkout. So we check out, that does a git checkout of the repository. We then obtain the RISC OS build tool. We archive up all the sources. So actually we want to archive up everything, and all right, we'll create a row build file in there. And then we send the files online onto the build service. That sounds good to me. And then we go and extract from the version num file. Now version num's in a different place. Version num is actually in riscos/version num. So we just need to fix that up. So this will be the bit that actually gives us a version for each of the things that we end up releasing. And here we go, here's name. I need to replace this with DOM. This would automatically have been replaced if my code had worked, which it didn't. DOM. Because it should be DARM. We'll go like that, it's not a big deal. This magic here that does the version and leaf name, that's actually putting things into a special file that means that it ends up being propagated to the other variables, so I can use it in here. This uploads it to GitHub so that it can be used in other actions. And then we've got a special release job here. So this happens again after the build RISC OS job that was up there. We run it on Ubuntu as well, and we only build it when we've got a tag that starts with a V. We download the binary that we created in the previous step from the RISC OS build job, and then we create a release using this external action called release action. And we create it as a draft so that it's not going to be made obvious that this is a something that we've just built. And then we'll go and edit it and make it into a real binary. So that is pretty much all we need for the basics of building it. But we need to have a rowbuild.yaml file. Let's have a look down here. We should have a rowbuild.yaml lying around somewhere. There we go, rowbuild.yaml. So this is the thing that gets sent to the build environment itself, and this will go and set up some environment variables. I always set sys environment to rowbuild so that I've got something that I can base changes on. And down here we've got the scripts we want to run. So amu-f makefile target, I think that's meant to say target equals $name. It should have been replaced with DARM. Is that right? In any case, it's not right, because we need to, so if we have a look, this is going to run at the top level. We need to change directory into the RISC OS directory. And then we need to run makefile lib first. So we run build the library. That's this library here. Oh, it's actually called DARM that way. Okay. I'm not worried. Case things can be fixed later. So we want to build the library. And then if the library builds, we then want to go and build. We really should try and build everything, shouldn't we? So let's try building amu-f makefile example. That'll. Oh, actually, we do need to do this as an export. So there's a bunch of standard rules that are used for this, and they're the same as the Acorn-based makefile system. So there's an export rule, export libs, export header, and then there's an AMU build RAM and some others. Right now, this is not particularly difficult, so we'll just try and get it to work anyway. So I want to do makefile example. That's just builds like that, and then we want to build probably dis file, because that will show us that we've actually got things working. And then finally, if all of that works, we can use makefile module, and we'll build the module. Okay, so there's quite a bit of code here, so I suspect it's going to take a little while to build. Remember, the build service isn't very fast, partly because it's running on a slow machine, and partly because it's actually in Python and all the rest of it. These AMUs are actually proper RISC OS AMUs rather than the ones that I've got ported here. So, what do I do now? I want to go back to the. Oops, too far. Back to the GitHub workflows here. Because I think, yeah, timeout of 60 seconds. Let's make that a timeout of 10 minutes. Because I think if I have 60 seconds, it's going to time out almost immediately. So this might take a while, so we may end up having to go around this a few times and seeing how this is actually going to work. Which it might not. It may not work in the slightest. So let's have a see. We can test it without having to push the changes, but I think the first thing we're going to do is going to create a branch. So this is add CI builds. There we go, new branch. And then we need to see what files we've actually got in here. So we've got files that were added for .github and .rowbuilds.yaml. There's also a GitLab CI file that's been added as well, this one here. Now that is going to fail because I don't have it running in GitLab CI, so I'm actually just going to delete that file. If I was running it on my build system, on my servers here, it would be using the GitLab CI, but I'm not using it, so I don't need to do that. One other thing that's interesting is we actually need to build the internal header file as well. And I think we build that by building the tool normally. So I think, did we just run make? That's running a little slow. Yeah, I think that was all we needed to do. So let's go and add in. So this will build all the headers. Yes, because there was all the Python code that was building headers and things. I'd forgotten about that. Build the POSIX version to get headers. So we'll just do that. Run. Do we just run make, or do we need to run configure as well? No, there isn't a configure file. It's literally just running make, it looks like. Let's have a quick look at the README. Project's no longer maintained. Yeah, I know that. Capstone is something that I did consider, but it's big. It's big. And there are other ones. This is fine. Okay, let's have a go back to here. So let's just run the make and see what happens. I mean, it's entirely possible that this will just fail quite badly. But we'll see. Okay. Status. There we go. We've got the workflow file, row build, the CI file again, and that's it. fine. Git commit -a. First attempt to get CI builds working on DOM. We're going to build the POSIX version as we need the headers built, and then we'll send the sources to build service for building with those headers. We'll see. I mean, I'm not expecting this to work very well right now, but we will see how it goes. Save that, and then we'll push it. Git push. Right. So let's go back over here, and we can go back to the DOM project. Oops. Projects DOM. Oh, no, that's the... Oh, yeah, that is the right one. So we go here. I should be able to go to Actions. And we'll see that this is a job that we started. So it's starting to build. A bunch of warnings. We know about them. I don't know how quick this is going to be. This is being interestingly laggy. Build through the RISC OS build service. Oh, it's doing stuff. It's nice when it actually works. I mean, it's not exactly the fastest of systems, but it is working, which is quite good. Okay. So the likelihood here is that this will be a bunch of sitting around and waiting whilst this is building, which is a little frustrating, but we can cope with that. I expect this will fail when I get to one of the parts of the build, because I'm sure I'll have missed something. I mean, if it works, that'll be great, because we'll have something that's actually building, and we can start thinking about what we're actually going to do with it test-wise. I probably won't add any tests here, because the fact that it builds at all is actually kind of cool. Although actually we could have put a very simple test in that goes and disassembles things in memory. That would at least be, that might be kind of useful. Yeah, I think that might be kind of useful. How long's it taken? 1 minute and 40 seconds. Yeah, I mean, it'd be nice if I had a faster compiler or whatever on there, but a lot of this is down to how the emulator runs on Pyromaniac, and Pyromaniac's very slow, not optimized for speed Python code. One of the things I did consider ages ago was running this all and running parts of the build system under RPCMU, because it could run a bit faster then. But doing that is quite a bit more work, and also it's likely to be a bit risky. I have some ideas about it, but it's also not something that I think people actually care about. They haven't really cared about the build service in the first place. So I'm not really that worried. Oh, that was one of the libraries completed. Oh, yes. One part of this that's interesting is the fact that it goes and builds all the different variants. So now it's building the that was the module variant it built of the DARM library. It's now building the application variant in 32-bit. Then it'll go and build it in 26-bit. That's going to mean it's very slow. I wonder if I've got the option to turn off 26-bit builds. I never added that because it wasn't really worthwhile, but it's a possibility. There's definitely some scope for improvement with this. Yeah, we're going to be just sitting staring at the screen if I'm not careful here. So what I'm going to do is leave that running and see how we'll see how it goes when we've finished it. And in the meantime, I'm going to go and see if I can something or other. If I can, my brain's gone blank. Yeah, so one of the things we haven't done, if I flip over to the script here, so what we do here is we pull out of it a build, and this is flickering like crazy whilst it's updating both screens. I'm not really sure it's a very well thought out. This, yeah, I need to get more used to using OBS, but for now I think we're just going to put up with it. I don't want to be on this file. I want to be on the row build. Row build. There we are. Row build. So here we build the library, then we build the example, then we build dist file, then we build the module. And the result of all of that is that we get out a set of files, which we can go and copy. So let us create a directory. Oops. Create a directory called artifacts. That's usually what in fact, let's have a look down here. I actually call the directory artifacts. So this is artifacts in the top level where we were checked out. So we create a directory there. It's very confusing that cdir is create directory and not change directory. Just one of those RISC OS things. So create a directory called that, and then we'd like to copy the module from rm32. Actually, what's the module called? I've forgotten. Yes, rm32. Oh, in the RISC OS directory. Debugger. Well, that makes sense. rm32 debugger into up.artifacts.debugger. Without confirm, verbosely, without recursion, forcing overwrite. Yeah, that sounds good. And let's copy the dist file tool as well. So we've got a little tool that we can use. It's interesting, the other window is still updating, and so everything is running slow. I'm not sure if this is how you're meant to use OBS. Maybe you're not meant to have it capturing multiple full screens at once. Almost certainly you're not meant to, I suspect. There might be some improvements I can do here. Do I want to copy the example code? Probably not. Yeah, that'll do. And then that should build me the artifacts down there. Okay, so that's good enough for now. Let's commit that code. And I'm going to amend onto the original commit. So that means just any changes that I've got in here can now be just treated as the same as the last change, because I don't need to know everything's exactly the same. Right, we're coming up to 8 minutes and it still hasn't finished building the library. No, we're beyond 8 minutes. I can't read. Yeah, it says it's still building that library. It's doing the 26-bit version now. So that's not ideal. I think I'm going to need to do something a bit clever to fix that up, so that it doesn't build everything. And I'm not sure I can do that like quickly in this time. Let me have a quick think. And that pineapple juice is gone. We're on the tea again. I've already had half an hour and I've not managed to get anything done. Well, hardly anything. Yeah, 9 minutes, 20 seconds. We're going to time out very shortly. I mean, you know, I cut out. Right. So let's have a look at move files / makefile. Not makefile. What was it called? Lib exports. That's right. So this is the makefile for lib export. It does a whole bunch of things. I can turn off ASDs. That's by default. Okay. 32-bit, 26 bits. And turn off the exports. I could actually remove those two exports there from the build, and then it wouldn't do anything. No 32-bit libs. That's really nice. I've got the option to turn off 32-bit libs, but I haven't got the option to turn off 26-bit libs. That's what happens when it was such a long time ago that this was done. This was done back in 2004 or something, when 32-bit libs were taking a long time and I could cut them out. Okay. No lib file. Yeah, that I don't need the special target stuff. Okay. Right, there we go. If we look over here, we can see that Pyromaniac Pyro terminated. Code 124. And 124 is you ran out of time. So that's not a lot of good. But I had the idea that I could just turn off the builds for the 26-bit stuff. Export libs. What does export libs contain? Let's go to the top. Export libs. It just ends up with those values in. Interesting. If I also just open, because we include underscore exports here, there might be something special that gets done with that. export headers gets magically included, and then export libs. All right then. I have no idea if this is going to work. I'm going to try and mangle the libraries as we go into export libs, just to speed this up. And I'll have to rewrite parts of my makefile system later to make things a bit better. Of course, you'd never get this stuff on the RISC OS Open build system because they don't build anything for 26-bit anymore. Whereas I still build things that way. How do I do this then? So in here, exports is those, but I want to change export libs after the lib export here. So export libs colon equals. So colon equals means do it right now. Don't defer evaluation of this expression. And I want to remove two of the values. I can't remember how you do that. I think it's filter, but I just don't remember how to do it. GNU makefile filter out. I think it's filter out, yes. Filter out elements. So most of the functions that are inside AMU are actually the same as the ones that are in GNU Make. And so it's easier to go and just look it up in there. When Stuart Brody added them, I think it's Stuart Brody anyway, or whoever it was that was at Acorn that did it, they made it very simple to make this transition to be able to use functions. So any of the space separated list in the first half gets removed from the second half. Is that right? Contains all the objects that are not in mains. Okay, so that's... I mean, I'm assuming that filter out has been written. Double bracket, filter out, export libs. No, that's what I want to filter it out of. The things I want to filter out are... I've gone back to lib export. I want to filter out these two here, which are the 26-bit builds. Oops, let me just close exports. Don't really need that. There we go. So that one, and oh no, not comma, space. Is it ZM? ZM. Don't build for 26-bit. I have no idea if that's going to work or not. Hi Dave. Oh, and hello Micah Chengo. We have other people here. Hello. I'll wave at the right camera this time. Hopefully this will all be coming out okay. Right, so yes, I'm just going to commit this as remove the export of the 26-bit. Takes a very long time on the build service. So emulator. We don't need the 26-bit libraries. So hopefully this will remove them. this change will remove them. And then we can go and push that and cross our fingers, I suppose. Oh, yes, push forced update. Force and update, sorry. Okay, let's, a new attempt at this workflow will be started, including... Did I do that? Anyway, this is the new one. And so this should take about, might take about 5 minutes even still. It would be nice if I could build the library, push it somewhere, and then have it downloaded for use. That would make more sense, but I probably need to think about that a bit more. So this is going to take a little while, so let's leave that for now. What can I do whilst I'm waiting? Oh, actually, I know what I can do whilst I'm waiting. I can have a look at the board, because if we spin back to the top here and I open this project in another window, come on, you're gonna open a little thing for me. Right click isn't doing anything. I think because this window's animating, it's just sucking away what the life out of my machine. Yeah, that's interesting. Let's just open that into a new tab. Yeah, so command syntax in help is untidy. We can fix that whilst we're waiting for things. What I'll do is I'll just pop back to here and then go back to the action we were looking at, and it'll spin down there. Right, I can jump between them a bit more easily now. There we go. So command syntax in help is untidy. So let's have a see what notes I made. For some reason, the help messages which have add syntax don't have a new line after them. Are we required to include that ourselves in the help text? That's a very good question, and not one I know the answer to. So let's have a quick look at one that already exists. So this is the sources for various modules I wrote some years ago. Let's have a look at, well, something's got to have clipboard. Clipboard must have a CMHG file in it. Clipboard holder, here we go. What does it look like? So here's the error identifiers it's got. SWI decoding table. Oh, okay. I wasn't very helpful in my clipboard commands there, apparently. Let's not use that one then. Let's look for something else. I know that in desktop icon borders, we've got icon borders round, which has a much more complex CMHG file. I think it does anyway. So we've got the help text here. It says help text, and at the end of it I have included a /n, and then the syntax is an invalid syntax, has got all those in it. Okay. And I've got a note of all of the different options that it actually is predicated on. Yeah, it was terrifying, was with icon border. Right, okay, so that's how you do it. Let me just confirm what we've actually got here. So we do pyro dev common load module. Yeah, that one there. And we might as well start a GOS, not a basic for that. Dum dum dum. Thank you. Help. What commands have we got in Debugger? Help dump I. Yeah, that's why. So it's not put this on a new line on the end of it. So let's sort that out whilst we're here. CMHG modhead. Right, so that probably means that all of these that have got invalid syntaxes need help text that ends in /n. Help text ending in /n. Like that. Okay, so in theory, if we now build that, that's a handy command. That's build it and then drop me into the debugger. Cool. Help dump I. That's better. You'll notice here that it's truncating there. That's because it thinks that the size of the window is much smaller. Basic print mode. It thinks we're in mode 27, and so it's formatted for mode 27. Actually, that seems small for mode 27. Mode 27. Apparently that's right. Fair enough. But that's come out okay. So we do help. Start help memory I as well. Help start memory. Help. What's the other one? Show regs. Yeah. So those are all nicely tidied up now. So actually, what I should have done is I should have moved this from to do to in progress. And then you can see we're doing it. Get out of there. Right, so I was working on CI builds, but I've just fixed this other thing. So let's get out of there. Check out a fix help messages branch. Help messages, yes, that's from master. Commit the code. Tidy up the help messages. That'll do. Oops. The syntax messages weren't appearing in the right place. They didn't have a new line between them. There you do now. All right. So with that done, I can now push that as well. That won't get tested because the other one hasn't, the other testing code hasn't completed. Let's just swap back and see how far it's got through. It's still building, and it looks like it's still building the 26-bit code. So my nasty fix didn't work, which is irritating. It means that I'm not going to be able to do this CI build in quite that way. But I can use my head. Even if those filter outs didn't work, I can still do something different. So back over here. Oh, hang on. Just toggle that away so it doesn't keep updating. If in the lib export So lib exports is all of those. If instead it was just those two, and my export target, where's my export target? Clean target, init target. Export colon. No. Export libs. I actually don't know how this works. This is the right file. Default is all. That's all good. No, but I definitely target an export target, don't I? Surely. Surely. Oh, it probably comes out of exports, doesn't it? The file that I closed. Yes, exports actually does the work. It does export libs and export headers. All export is those, and that bases it on all exports and export headers. So, try it a different way. Go back to the CI branch that I was working on. Yep, there we are. And then have a look at our makefile lib again. Right, so this magic didn't work, but I could do export limited, which does export and export libs, and instead of doing these two, filtered out, if instead we filter in the 32-bit versions, that should do the job. Yeah, I'm making it up as I go along here. I have vague recollections of how this was meant to work, but I clearly didn't quite do it right. We have a nice friendly dog next door that gets very excited when it sees people. Dave has just mentioned that the dog's agreeing. I didn't realise it was audible in here. He barks quite a bit at me, but never barks at Talia. It's very strange. Or maybe not strange, maybe I'm just a strange one and that's why he barks at me. Right, so export limited. So instead of doing the build here with, oh, it's not in here, it's in row build, isn't it? Sorry. Yeah, instead of targeting export, if we do export limited, I think it will go and just build part of it. That's the worst that can happen. Log. Yeah, so this is meant to be, this is the same as the previous change that didn't work, but we're doing it a different way. So I'll just replace that change and push it. And we have a look over here, and we'll see that this last one didn't work for the same reason. It was spending too long building stuff, which is unfortunate. I mean, I am assuming that we can get both the 26-bit, the 32-bit module and the 26-bit module. No, 32-bit module and 32-bit application libraries built in the time. I don't know if that's going to be there. We'll have a see. We'll have a see. Right, so we've got remove the export of the 32-bit libraries, of the 26-bit libraries there. Cool, that's going. Right. Come on, thank you. We've done that. Well, it's on a branch at the moment. Actually, since it's not, I could just merge it, couldn't I? I mean, there's no reason to put it on a branch. Master git merge. What was it called? I've forgotten what the branch was called already. Fix help commands. Oh, I'll do minimize no FF, just so we actually get a merge commit in there. Not something we can merge. Help messages, sorry, got text wrong. Right, so that's now on master, which means that we can safely say that this is done, which is good. Having done things is always handy. Right, error returns. Let's have a quick look at that. The commands and swis don't really return errors very well, sometimes not at all. We should include error messages in the header and get them returned. Yes, we should. Okay, we'll do that. So the thing we need to know is, what are the errors? They're things like this, I suppose. So this will be something like error cannot pass memory, star memory. Let's do that. Okay. Just do one of those to begin with. So CMHG file. There we go. Come on, where's the error? Event handlers, vector traps, generic library enter code, why decoding code, error base and error identifiers. Here we are. I haven't got an error base allocated, so let's just fix me not allocate. Ooh! That's what we should do. I'm now working on this, so let's go and mark that as in progress. Yep, there we go. And then add another item to here, which is register the error base. Oh, do I need to register it? No, I should just use the debugger register base, shouldn't I? Error base. There we go. And that is a, I'll put a description in then if you want it. Nasty base of n equal. There we go. Update comment. Convert it into an issue. I don't know why it doesn't create them immediately as an issue. It would be really nice. And then I can label it because this is now a bug. Ding. There we go. Right. Error identifiers. I've already forgotten what the error message was. So cannot pass start memory is the variable name. Cannot pass start memory. Add start memory syntax. That'll do for now. I'm not being very imaginative with that one, I'm afraid, but it'll do. So that's one. Let's actually go and test that that works. So RISC OS ammo. Come on. Memory Bob. That doesn't look right. In fact, that looks kind of wrong. What the heck? Apparently that actually understood it and decided it was going to try and process it. And was using 0 page as the address. How odd. Star memory Bob. Give me the first 80 lines, please. Oh, balls. That's all coming out on stud error. Stop. 271. Yeah, so it just passes straight through and tries processing it. That's not good. Okay, let's go back to where you were. Thank you. And let's have a look at what we did. So this is in star memory. Parse memory parameters didn't return a failure, apparently. So let's have a look at what parse memory parameters does. Hiya, Paolo. Parse value or reg is meant to return null if we didn't get anything. So that's kind of interesting because it does mean that this isn't being parsed particularly well, because when we get no parameters and when we get invalid parameters, they look the same. The error handling just doesn't differentiate between the two cases. Which isn't very helpful, really. That's annoying. That's annoying. So what happens? So what actually happens? So parse reg or value. When we pass in Bob, we get, is it a space? No. Is it less than a space? No. Can we do anything with it? Is it a register? No. Can we read some hex? So we'll go through the read hex thing and we'll get back something that isn't the same. So B would be hex, and then the next thing would come back as being not a space. What does os read unsigned return if you give it rubbish? So I'm calling os read unsigned here. I'm setting the resulting args to be null. So I'm saying, so if there's a problem, we set it to be null. So it's just, that means that we end up going through there. I'm going to change how the parameters work. This is just bad design on my part. I didn't think through the error handling case, because in the Python code it didn't matter. I could just like not care. Is it? Sorry, which one is it I'm doing here? This is the. I just scroll down to where I was. Sorry, I've forgotten what I was doing. Pass value or reg calls into read hex, and it returns a param, which is a parameter. So if I go and put in here an int invalid, I can actually populate that with params to invalid equals 1. So we start out as invalid, didn't pass it, so that's null. If it's a space, that's fine. If there was no parameter, then it's not valid, isn't it? Yeah, that's invalid as well. So if it's not valid, I don't need to do anything. If we get to the end here and we're returning something, then it's valid. Params to invalid equals 0. If args ends up being null, how do we get back args from that? Oh, we return the pointer, don't we? Yeah, that's right. Then it's invalid, and we can just return here with it being invalid. Fetch register. That can return 0. Oh, but there's no distinction between an invalid response and the value that's correct. So we'll leave that for now. Put some braces around that to make those the same. Right. So now any calls to pass value or reg should probably also check whether it got back something that was invalid. Yeah, could return an error there. Maybe we should have a enum of the error types. Enum of the error types. Actually, whilst I was thinking about it, if is greater than or equal to a space, if it's a real character and args is not equal to a plus and if it's a real character, not a space, it's not equal to minus, then string might have been Bob or similar. It starts out as a hex but is suffixed. And that's also invalid. I mean, I'm special casing the specific case that I've done there, but that should catch a number of others as well. invalid or other param invalid or third param invalid, return 0. If any of those failed, I think that's right. Not feeling especially confident that I've done the right thing here, but let's have a see. Bad star memory. Oh, that's correct. Yes, because Bob is invalid. Right, let's go and do a GOS, and we can try out some examples. Memory I Bob, invalid. Good. B OB, also invalid. 8,000. That's not invalid. That should be valid. Bother. What does that mean then? Which one actually failed? I'm not sure how that, because it's not ours, is not null. Oh, these are valid. These are valid cases. Hello, Larry Page. Wasn't Larry Page the guy at Oracle? No, I don't know. I don't know my computing history, apparently. No, invalid equals not. Those are both valid cases. Maybe I shouldn't have called this invalid. Maybe I should have called it valid. Ah, the problems you get. Ah, BBC Music Video Guy. Fair enough. Hello. Right, I can disassemble at 8,000 now. Good. And do you ever stop? Good, you do stop. Also, I want Ellison is the Oracle guy. I'm glad other people remember these things. I'm useless, clearly. That worked. Bob. B Bob. Plus 8,000 plus Bob. I should write some proper tests for this, but I'm going to feel that that's at least returning an error code right now. If anybody else feels they want to improve this, then feel free to create some pull requests, and we'll be able to add some more bits in. Let's see if the other build we were waiting for has completed, shall we? It failed. libc-darm-o not found. So that means that one of the directories it should have created, it hasn't created. It was in the process of building it. It only took 2 minutes. So what would have created that? Let's see there. All right, then in the exports thing. Cedar. Oh, it's probably muckdir, isn't it? Export initdir. Ah, if you export headers, or that you always get export initdir as well. That's what I missed out. Okay, so let's go back to the make file for the library. Yes. Oh, I'm back on master. That's why. Okay, let's just stash these away for a moment. Back to the old branch that we're doing CI testing on. There we go. And add in, I forgot what it's called, exporting it to git commit -a -limit. Is that the only change I've got? Yes. Commit. Yeah. Push that as well. Back to master. Unstash where we were. And we're back where we were. Okay. Ooh. Oh, that's now in 20 minutes. I still haven't got a single thing finished. Oh, I have finished something, haven't I? Yes, I finished doing the adding a new line to the help text. Yeah, remembering that I've actually finished something, but it was pretty pathetic, is counterproductive. We'll get this sorted. Okay, what was I doing? So I'm in the middle of fixing invalid error. Error parsing, that's right. So if we go back to our veneers again, we should be able to add in some other error handling. We don't actually need these messages saying that the module's initialized and finalized. What I'm going to do is I'm going to make them debug options. So there's a relatively common trick that I've picked up on doing for this. So hash define debug. I'm reminded that every failure is a step to success. What's the thing? WD-40. It's the 40th revision. Nobody knows what the 39 before it were, but WD-40 worked. Didn't want define. If def debug define dprintf if one printf else define dprintf. So we end up with a little function which, if we're defining for debug, we're building with debug, we get printf, otherwise we don't. And I will turn off the debug. There you go, debug turned off. And then dprintf, so those will just vanish, but if we turn on debugging, they'll come back again. Right, mod commands doesn't do anything, it isn't necessary. Dave's just suggested that WD-41 displaces pineapple juice as opposed to water. Yeah, so actually we've got exactly the same error message on this one. So I can copy this section that did the cannot pass star memory. Although the error message will be slightly wrong now, because it'll say bad syntax for star memory. Do you have a separate error for each of them? I'm going to have a separate error message for each of them, just because then you can actually tailor them to be more appropriate if you wanted. Oh, went a bit far there. Copy that. Bad star memory I syntax. With the fishy ingredients? Did WD-40 have fishy things in it? I really don't know my WD-40 history. Okay, that's that one. Ooh. That doesn't return any errors there. Should it? Disassemble memory. I think the only error we've actually got at the moment is for the failure to open the file on dump_i. So yeah, there's this. Oh, there we go. That's the same. That's the wrong syntax. Let's just go back to this. This error decoder here is the same, but this time for dump_i. If we wanted to do translations, we could have these as error blocks that have got the tokens in and then look them up, but I haven't seen any particular need to do that myself. Doesn't feel like a especially important one at the moment. And it's relatively easy to do later on, so you can just add it later. Translations, so long as you've at least vaguely thought about it, can be done later. Apparently it's a myth that WD-40 multi-use product contains fish oil. Coding with Gerph, learning how myths from around the world. I didn't know that. I mean, I wasn't really aware that it was a thing even, but maybe I don't remember. It does feel like something I would have picked up on when I was a child. So, right, file not found. Ooh, we can actually have that as a file not found error. We can make that better, can't we? So kernel os error star row error. Oh gosh, remind me how this works. I think it's fs control, no, fos file. Right, Swix os file. No, I think 2, 4. I think it's 19, and I think it's given the file name and an object type. That's only 2 registers. I think that's how you do it. Let's go and have a look. Find os file. I'm going to go for 19 straight away. Oh, all right, we're not. We're just going to use os file. Os file vector. There we go. Os file reason code. I'm assuming the reason code's in the next page. Yeah, here we go. Generate error message on page. Oh, I'm kind of embarrassed that I'm actually right on that. Cool. So to return a file not found error, you just do that, and then you do return row error. So what? WD-40 company does not recommend using WD-40 multi-use product to attract fish. Sometimes there are no words. Right, this is me testing the different commands. So, dump_i of foo. Foo doesn't exist, so I get now a proper error message that says file foo not found. That's cool. And if I do memory I bob, bad memory I syntax, dump_i file name that does exist. Oh, actually, I think of foo and then bob there. File bad number ob. Slightly different error message. That's not bad. Memory I, dump_i. Those are the ones that I've done. Put and error here. An error here. Let's put an error there then. Bad syntax in store. just going to ignore some of the chats. It's taken a decidedly strange turn. Comma. I forgot one tip. It's turned out to be a little bit like that, the overheard conversation on the other side of the room, when the room's quite busy and you're going, I'm not sure I heard that right. Bad syntax for start init store. I'm not sure these are really particularly good error messages, but they'll be fine for now. Right, that was init store. And show regs we already know has a syntax error because it's just the standard syntax. Okay. Let's just quickly do init store and then we'll be good. Init store Bob. Bad syntax. Cool. So that gives us I'm being reminded that I'm about halfway through, which means I should probably finish up what I'm doing and try and get something that is committed, and then I can have a short break. Yeah. What have I done? So, this is fixing... Yeah. Commit minus A. Fix for... Oh, no, not fix for. Added error message. Error returns when commands cannot be passed. An unrecognized string. Cool. Apparently there's about 20 seconds lag. This is quite cool, actually. I thought it was a couple of minutes. Because we've got an unrecognized string, we now return a RISC OS error. So, and another thing that I've changed, another thing I have changed in this session is I've changed how I do the encoding. So it's now using the lowest quality encoding that's the fastest, and that means that the machine is a little bit more responsive for me. So if you're seeing any artifacts and the like, and it's a problem, let me know and I'll try and tweak things. There we go. Let's have a look at what we did last time on this thing. It still failed. But it did fail after 5 minutes this time, which is much better. Get exception area. Oh, that's interesting, isn't it? This is actually, I'm guessing, a real bug. What are we building? We're building... what are we building? This file. Make... No. RISC OS. No. Where did I make file? This file. And then try running it. Yeah! That's broken! Cool, okay, so let's fix that. This file needs something. Wasn't a piece of assembler, was it? Get exception area. Oh, it's in introspection, isn't it? Introspection. I'm always happy when my testing finds bugs, even if it wasn't great. Oh, also, yeah, I do need default CPU registers as well. I was at work on Friday, and one of the people I work with came to me and said that our intern's tests had actually pulled up a real bug in some of his code. I'm like, yep, that's why we do it. I was really pleased as well because he's undergraduate student who's come to work for us for a little while. Cool, that now works, which means go back to the CI build branch and let's commit that, and that should fix the dis file build problem. Git commit -a. This file failing to build. This file wasn't linking with the newly added components, not components, objects for introspection. Now link with it, and CI should enable build. Alright, let's push that, and it's going to take about 5 minutes for that to build. So if I go back here and spin to the top and leave it on the actions, we should have that building. So what I'm going to do is I'm going to go and take a break for 5 or 10 minutes, and by the time we get back, in theory, that's built. I don't know if anybody else can actually see the results of the actions output, but if it is, you can watch it and see what's going on. In the meanwhile, I shall go and take a short break. A little bit of a rest. Okay, back soon. Hello. I'm back, having been WD-40'd quite liberally. Or possibly pineapple juiced. You choose. Okay. We have a failure again. What went wrong? It got right to the end and then failed because I give it the wrong blooming file name. That's quite frustrating. All right, let's go fix that. That was also quite inevitable, I think is the word, isn't it? Ah, dear me, do I feel stupid? It's not in there, it's in row build. Yes, it's not in there, it's AF32. Oh. Well, that's okay, that's okay. We'll just... What was my last commit? Fix for this file failing to build. We can fix that in the same commit rather than having a separate little one. And export. It wasn't created because the source directory was wrong. And that took 6 minutes and 50 seconds, apparently. So, yeah, this is what it says, 6 minutes, 50 seconds. So in theory, I can now go and make it run again and hopefully it will complete. It's in actions here. Here. And whilst we remember, if I go back to the top here, we go to the task boards. I fixed the error returns now. So if I go back to master, I had pushed that, so I can now say that that is also complete. You're going to drag. There we go, drag to there please. There we go, error returns is done. Which is pretty good. So, what have we got done so far? Tidied up the help syntax, that's pretty cool. The error returns fixed, which is also pretty cool. CI build is nearly there. We'll have that sorted shortly, hopefully. And then the next thing that I said I was going to have a look at was the star memory A command. So we have a look down here. There's a priority option on this. Somewhere down here, star memory A command. So this is a pretty different command, and it's also way more than I remember it being. I don't remember it having a lot of options on it, but that's probably just me. So if we go down to the manuals, debugger, here's the debugger module. There's the commands, and there's a link to star memory A. No, there's not a link that. Probably fix that. Break list, break set, continue, debug, init store, memory A. Here we go. So memory A's syntax is can be a byte option, address or register, and then an explicit value or register to apply to. And this is all new to me because I rarely use this. The first character shows the direction in which return steps, plus for forwards, minus for backwards. The next address of the word being altered, then the character on that word boundary. You may type any of the following at the prompt. Minus to go back in memory, plus to go forwards, or some hex values to alter it, or dots to exit. Genuinely, never knew this. This is all news to me. Okay. So let's go to the module header and add those commands. That syntax. It's very similar to memory A. It's kind of similar to. Let's see. Copy paste. There we go. Memory A. Minimum arguments. Well, let's just write the syntax first, because then we'll be able to count them. Memory A. Actually, it's closer to this one, isn't it? It's closer to memory standard command. A byte, a word, a half word, an address, and then just a value, which is closer to what init store does. I mean, I don't actually have to implement this in exactly the same way. It could be implemented in any other number of ways. So this is value or reg. I'll just notice that the syntax for init store says reg1. We don't really need reg1 on there, do we? Let's take that out now. Let's just register. Oh, actually it's reg2, isn't it? Yeah, I'll do that. Start memory A, alters memory. Actually, it displays and alters memory is actually the help message. Okay, I now have a syntax. So what we've got possibly 1, 2, 3, but we must have 1. Okay, let's pop back over here, mark this as being in progress, close the window, and let's have a look at how our building's going. It's built this file. It's now... Is that building the module? Yep, that's building the module. So we're on the module. We must have only about a minute left to go. Let's watch this and see whether it works. Feel the excitement, the joy, the thrills, the complete boredom. Mem declared but not used. I'm not fixing that just now. It's possible I should make warnings into errors for at least the module. But for now it's not a big issue. Got the veneer compiling. Yeah, another warning there that could be an error. I can have a look at that later, or somebody can fix it for me. Linking, copying, completed, and success! We have a successful build! Whee! Yes, that's me being happy. Right, so that means that we've got those two. If I reload this page, ooh, it shows little Linuxes beside it, little tuxes. I didn't know that. I really haven't been paying attention. Summary. Here we go. Artifacts. RISC OS build. 48K. Can we actually have a look at it? We can't, can we? Yeah, I think that just tried to download it. Okay, let's have a see what it did. We go back over here. Unzip -l /downloads /RISC OS build 1. Huh. Yeah. Oh, I know what that is. There's some oddity with how completion works. RISC OS build. That's the one there. Unzip -L. It's an archive containing an archive. Let's just extract it. Unzip -L dom 0.02.zip. So that 002 has come out of the version num file. And we have a debugger and a dis file. That's pretty cool. So those should be downloadable on any RISC OS system. They're only available in the artifacts at the moment. We'll do a release before we finish today. Actually, we'll do a release, yeah. Should we do a release now? So we'll just put the changes for memory A on hold. So all I've done is just added the syntax there. That's not a big deal. So let's stash those away because we don't need them right now. And we'll merge in. Go fast forward. What was it called? Add CI. Add CI builds. There we go. Merge that in. And then we can push it. And that should work. Now we can continue on doing this stuff. So that's going to do a build on master, and then we'll go and tag it with a V. So V. Ooh, should I have incremented the version number? Yeah, we'll call this 0.02. Actually, I don't want to do that. No, let's stop that. And let's increment the version number. Can we stop that from here? Please. That's not doing. Cancel run. There we go. Right. So what I wanted to do was increment the version number. So we actually have 0.03. Come on. Manage inc. Please. Version number now 0.03. Git commit -A. There we go. Git tag v 0.03 and then push. Right, there we go. And I'm going to wait for the build to complete, and then I'll go and push the version. I won't do it until afterwards. CI build is now complete. And we're working on memory A. And trying to release it. Okay. Unstash. And then go back, do a make of the module, and it should fail. Doesn't fail, does it? Because it's a weak reference we create. So we just need to create the memory A command. Let's go to the bottom. Find a memory. So I said it was kind of like star memory, didn't I? So let's start from this. So it looks like this one, then that will make things a lot easier. Copy, paste. So star memory A has the width, the same width thing that we had before. And then it has at the ending of it not those three values, but the same thing we had in its store, which was oh, so we just read it like this. Oh, that's easy. Pass value or reg. Huh, okay, well, that will do the job. Something went ting. It's all right, not important. Dum, dum, dum. Actually, just give me a second. I can just answer this person, and I'll be back. There we go. Not sure it's particularly good etiquette to go and take messages whilst I'm doing things, but I'm learning this stuff. We'll see what I can do. Anyway, right, what I was doing. So this is the star memory A. So it's star memory A, and it takes a value or a register. So we've got two value or registers. Actually, we've got the data width parser, which is as we expect, and then and then we've got the same thing again. So let's get rid of, we don't need these memory parameters because they're not the same. We're not doing a dump memory, we're going to do something different, obviously. It's going to probably be very similar because the syntax is similar. I want to pinch the code that I used down here in init store. And init store, here we are. So this bit here is what the value is, and this is an optional one, so grab that. Yeah. And we put it in here. So this code is, it retrieves a value if we haven't run out of arguments. So actually, not if arg string is, if arg says it should be arg string to null, which it shouldn't be anyway. That's optional. That's optional. Oh, I want the address and register down there. So yeah, okay, let's do this way. Oh, my pointer's being so terribly slow. It's wobbling all over the place. Oh dear. Char star, no, not char star. uint 32 integral t address. So that's the address we're going to be processing. So first thing to do is to pass the, this is not bad syntax in its store, this is bad syntax memory A. Value is the value we've got back. So this is going to be the address or register we're pulling out of here. So we should change that to be address. Yeah. And that's got bad syntax error. And then we can pass a second one. Ooh, hang on. If argstring equals null, then it's a bad syntax. Or param.invalid. If we get back param invalid, it's also invalid. Or param.invalid. This is, yeah, we probably should do this better, but it doesn't matter. But the string could be null to mean there's nothing there. If there's nothing there, then we don't need to worry about it. It's only parameter invalid. Value equals that. So let me just look at this. It says in the instructions, displays and alters memory in bytes if the option B is given or in words otherwise. Well, we're also going to allow half words. If given no further parameters, interactive mode is entered. Each line similar to the following. Okay. Or for byte mode, that way. Okay. As an alternative to using command interactively, you can give a new data value on the line after the address. And that's it. That's the entire help. So if a single thing has been given, then we do that. If multiple have been given, if nothing has been given, we go interactive. So let's have a int interactive. If we passed something, string, interactive is false. 0. I haven't got stud bool. Else interactive equals 1. Yeah, there. Okay, let's have a look at our build and see that the build worked. Incremented version number 3 looks good. So I just need to push the tag now. Origin v0.03. That'll push the tag, and I think that generates another workflow as well, because that is actually doing the release. There we go. Okay, all right, back to here. We're still getting the star memory A implemented. So this should be quite easy, really. If I've got those interactives back to front, haven't I? I've got them back to front. If we didn't have a third parameter, then we are interactive. If we did have a third parameter, we are not interactive. If we're not interactive, write the value right now. If data width is 1, start uint 8t address equals value. Else if data width, so here we go, depending on what the width they were trying to access, we now can write each individual set of values to it. And if the value width is 4, uint 32. There we go. That looks okay to me, I think. So finally, printf wrote %x to. Should I do one of these in each case? So I write exactly the right width of it. Yeah, let's do it that way. I'm not too fussed. Ooh, I'll put that in the wrong place. value and 5 to address. I can actually put the size down here. There and there. This is writing a word, so I don't need to mask the value off. And this is writing a half word, so I do need to mask it off. Go. It's in there, and it's not a word, it's a half word. Half word. Yeah, that looks okay. Let's see if that builds. Run the build. No, it did not. Lots of long mismatches, so let's fix those up quickly. Put an L before everything. I might need to do some casting around here, I guess. Implicit cast of non-zero int to pointer. 63. Bad syntax memory. Ah, that's why. Right. Okay, well, let's add that to the header as well. Missed it. I saw it go by. There we go. I've not kept these error variable names very consistent. I would tidy those up, but I've not had the time to do so. Okay, let's give that a whirl. I think that's actually going to be okay. Oh no! Oh, I missed a comma. I missed a comma. All right. Oh, that cup's empty. The emergency flask of pineapple juice time. There we go. All good. Right. So, memory A, I'm so used to typing memory I, 8000, 987654. That's not right. That's doing a star memory. I bet I forgot to change the command that it invokes. Yep. Handler. Memory A. Come on. Yeah, thank you. Memory A 9876. Rote word 987654 to 8000. And if we just try and display that, just the first word, first two words in fact. Let's do that. It has written 987654. Cool. Let's do that as a, oh hang on, no, wrong one. Do that as a byte, please. And it should just write the, oh, I need to do it at a different place. Do it at 9000. Oh dear, that did not go well. Oh dear. Right. We wrote to address 0. We wrote to address 8 a word. Data around the watch point contained a bunch of things. The executing code block was just before the wrote word blah to there. Oh, I don't think I support lowercase b, do I, as the byte? So that's actually given us 3 arguments. And therefore gone a bit funny. Yeah, so we wrote 9,000 to store R5. R5 contains 9,000. Yes, it tried storing R9 value 9,000 to address B, which is in the word at 8. Okay, let's try that again. And that's generated a valid alert. So we change it to using B for a byte. We wrote a byte to 9,000. 9,000 plus 8, 54. And if I go and write a half word to AOO, I should get 7654. It's AOO. 7654. Brilliant. Okay. Non-interactive is now working. What time is it? 2 hours 16. Yeah, we can get a bit of interactiveness doing. But this is working, so what I'm gonna do is I'm gonna go and size this back again. I'm gonna create a new error message. New error message. I've scrolled past it. Oh, it was there. It was there. I missed it. For saying we don't support interactive just yet. No support for star memory A interactive. Copy, and then else return. Let's just lose that for a moment. And we're not interactive. Okay. Rebuild. What did I miss this time? 179. Did I do something stupid? Did maybe spot it? 179. Oh, it was in the error block then. I missed a comma, didn't I? I missed a blooming comma again. Yeah. Simranj is great, but it's a little unforgiving when you get something slightly wrong. Maybe that's not a bad thing. You don't want them guessing what to do. Star memory A, 9,000. No support for memory A interactive. Brilliant. Okay. Added support for star memory A, not interactive. We don't support the interactive form of star memory A, but the immediate form is done. Cool. That's not complete. We're not finished that, but we have finished doing this particular block of work. I'm just going to jump back here to the board again, and we can have a look at whether that workflow completed. It did. So version 003 is now present, which means that we can go over to the code section, and hiding away on this right-hand side, you can see the releases. And there is now a release present there. this has been given a draft identifier, so let's go and edit it and make it an actual release. I never know what to write in these things, so this is initial release. This is of the DARM based debugger module for RISC OS. Features supported. Star memory I. Star memory A, not interactive. Oh, actually, no, that's not in the version we released of 0.03 doesn't actually support memory A yet, but the others do. So dump I. Like star memory I, but for files. I'm very used to having dump I because you've got it in Pyromaniac for ages, but oh, I didn't mean to do that. Init store. Oops, star init store. It's very frustrating. The Mac doesn't support end as being end of line, and I have to keep watching it. I keep pressing the wrong key. And show regs. Debugger, so swy. Debugger underscore disassemble. No disassemble, Stephanie. I'm sorry. I think I've used that before. Not disassemble arc, disassemble thumb, sorry. So we support ARM, we support thumb. What else do we support? So show regs with exception region extensions. Yeah, Control A and Control E. I just keep forgetting. I've been using the Windows at work far too much, and so I'm back to having that as a thing. I think that's all the features we've got in there. Is there anything else I've missed? I fixed some bugs, but then this hasn't been released, so there's no point in mentioning it. Command left and right too. Oh! Oh, I didn't know that one. Command left and right is start and end of line. That might be useful to know. I'll try and remember that one. Right, I think that's good for publishing. So, oh, there's generate with it. That's new. I might try that next time round. That would be quite cute. Publish release. Right, so if anybody wants to download that and try it on like real systems, I'm reasonably sure it should work. I mean, I'm not 100% certain because I've only tested it on Pyro and that's about it. But probably it'll work. And we have a release. And I'm in the process of doing star memory A. Shall I go and do the interactive bits? Should we do that? Yeah, what the heck. I mean, I'm genuinely unsure how well this is going to work, but let's give it a whirl nonetheless. Right. When interactive, we output a string like plus address colon ASCII colon value. Oh, they actually include the disassembly as well. And then enter new value, which is very like 1980s-ish, isn't it? A very, very explicit prompt like that. Okay, so we'll keep a flag to say whether we're quitting or not. We'll keep a flag that indicates the direction. Yeah, we'll use it as a value, I think. Value of the direction. We know the address. Can I pinch any of the code that we used for the row disk code here? Disassemble words. That disassembles one word. Yeah, fair enough. Debugger disassemble. Oh no, it's in memory I, isn't it? The stuff we did for how it disassembles a line. Oh, and that uses the memory accessor, so I'd have to set all that up as well. On the other hand, that output is exactly what I want, isn't it? At least for the word output. And since it is exactly what I want, it feels like I should reuse it. Yes, I think I should reuse that. It always makes sense to try and reuse things when you've got them. So, disassemble stuff. I need to create a data accessor. And we can use thumb for some of it. I'm going to have to do the byte things separately. Yeah, I'm going to have to do byte separately, I think. But it's either that or change. Oh, is that disassembling a chunk? It is disassembling a chunk. But I just specify the start and the end as being the same address. Or the next address sort of thing. Yeah, that I think that sounds good. So in fact, the binary one is going to be just dump stuff. So either way, I'm going to want a data accessor. Create file accessor. Come on, isn't there a create memory accessor? Oh, we didn't actually have a create memory accessor because it was just so rudimentary. Nonetheless, I think I should probably have a function that does. It's more sensible to have a function that does the job. So that they're consistent. Not create, initialize. Void create memory. Memory. all we do, because this is accessing memory with no translations, I think we probably would want something that had translations in the future. That would make it a little bit more flexible. But right now this is just fine. And then we can just call it in here. And I think dump file, dump memory. Yeah, so this has got the same thing in it. There we go. So in the future we can make that more flexible if we want to. Oh, I probably also want to export the function, don't I? Copy it so it's exported, so because I'm going to need to access it in the veneer. Then the I. Ooh, neither create accessor is actually. Oh, in fact, the accessor isn't actually even exported here. Interesting. Go back to here. Oh, that's frustrating. Because that means I would need to actually export the actual blocks here, the data accessor blocks. I mean, strictly, they could go into an accessor library as well. I'm going to just put them here for now, because I may as well. And then later on, we can move them into a library to make them a little bit more generic. Because they are pretty nice little bits to use elsewhere. Where's the create file accessor? There we go. I'm not sure I even need to do this. I'm not sure I even needed to do this, because what I actually want to do is to call disassemble memory on a block and then disassemble dump memory. Oh, excuse me, sorry about that. Oh, blue. Yeah, I probably didn't need to do that. But for now, I mean, that's not going to hurt us. We've now got the necessary bits in there that we need. So, yeah, that's not going to hurt us. I gotta bless you. All right, so while we haven't been quit, we want to, if direction, actually we can just do this as a printf with a conditional. Printf thank you. If direction is 1, then put a plus up. Otherwise, put a minus up. And we probably want to follow that with a space as well, so that we can, yeah, like that. And then, if data width is 2 or data width is 4, I want to do the disassembly one, which is, I've forgotten already. I've forgotten already what the blooming thing is. Back to memory I. Disassemble memory. Don't think we're going to get any errors back, so it's not going to matter here. I can ignore the return from that. If we ever validate whether the memory is valid or not, we could do something else, but for now this is fine. So the thumb setting is data width 2. And the start address is going to be the address we are currently on, and the end address is the address plus the data width. And if the data width 1, we can do dump memory. How does dump memory work? Dump memory, data width, start, end. Fine. Actually, we can just make that else rather than if it's 1, and then we can get it for any sort of types of data. If we include larger data widths in the future, it'll still be valid. Address plus data width. I'm going to put a break in there so we just stop. We won't actually prompt for anything, but we're just going to try and do it. Build a module and then run GOS. Come on. Memory A9000. That looks good. And then if I say do that as a byte, please. I printed out the whole lot. That's not right. Oh, there might be a bug with that. We'll have a look at that later. If I do star memory 9000 plus 4, does that display me the whole? Yeah, it does. That's a bug then, because that shouldn't be displaying me more space than expected. That's wrong. So yeah, we can look into that. I find it quite interesting that in ARM, the value 0 is ANDQ R0, 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 which is effectively a NOP, no operation. And in Thumb, the value 0 is MOV R0, R0, which is actually a NOP. It's the usual one you use for a NOP. In ARC64, the value 0 is an undefined instruction. In fact, all of the low values with 0 at the beginning are actually invalid instructions, I believe, which makes it quite interesting, because if you come across anything that is like regular data, you're more likely to give an exception with an undefined instruction rather than just execute onwards from there. I'm not sure if that was a security issue and a thing that they actually designed it like that. Well, I'm sure they did design it like that, but it's kind of cute. Anyway, now we want to read a line. So let us call readline. Let us remember how we call readline, because readline is a fun routine. So I want to get a line, really. Actually, I could just do get s, but then it won't be as nice because you've got a history. I want to do readline. Calling readline is actually a pain. Dave says that Thumb's official NOP is MOV R8, R8 for some reason. Well, that's weird. I didn't know that. How odd. Yeah, that's very odd. Okay, so I want to call readline. So the easiest way to do this is to actually just put it into a function. So no, I didn't need to do that. Char line. I want to get a line, and the maximum length we can have is going to be not 100. Let's say 12 bytes, because it could be a decimal value you're going to enter. So I'm going to leave it as 12 bytes. I'm going to call readline, and I want to readline into line of size line. I could actually just allow, no, I was going to say I could allow just numeric values, but you want to be able to do read unsigned, so 10 underscore 105, or possibly something bizarre like base 19, like that, to get a really odd number. You want to be able to accept that. So I'm not going to do any other particularly special commands there. Right. Success. Ooh, success equals that. If it was successful, it will go into line. Otherwise, it won't. Gone too far. If not successful, if something went wrong, we're out of our loop. Otherwise, if so it's plus was go forwards, direction equals 1. And then continue. Oh, do you want to continue? Yeah, we go back and we then print the next line. Oh no, not continue. No, we do want to step forwards. Yeah, the instructions aren't particularly. So I was just reading what the syntax was here. Next is the address being. You may type any of the following things. It doesn't say what the exact result is, so we're at liberty to change that. And of course, we can change the syntax anyway. We can make it do anything we want. It is only for user interactive use, so it's not like it's going to be a thing that people are going to automate. Well, if they do, then they really miss the point, because you could have done all this programmatically anyway. Right, if it's a minus, then the direction is backwards. If the line is empty, yes, I'm going to do it literally. If the line is empty, then we are going to the next location. That's do nothing, go to next location. And then apparently there's, copy that bit, copy, paste. Dot means we're finished, at which point we set quit. Otherwise, if it's hex digits, we process it. So what we'll do is not just hex digits, because we're going to be good, we're going to do the full register thing. And we've got the register reader up here. So read a parameter from line if end is null. So if we didn't understand it or it was invalid, we'll just print out could not parse. Printf cannot parse string. Ooh, did I put any? I think I put some new lines on the line there. Value equals param value, and then we go and assign it. Oh, hang on. No. That if we couldn't parse it, we want to continue. Or do we want to go back to the read line again? I didn't print out the message, did I? Into new value. Enter new value. And re-enter. Use a go-to. Yes, go-tos are bad, but sometimes they're quite useful. Re-enter. And this is where we want to write the value. Which is actually exactly the same code as we had up here. It'd be nice if that was actually a little function or something. For now, this will do. I could probably pull it out later. I do end up saying for now this will do quite a lot, I know. Some of that's because I'm lazy, and some of it's because you've got to just keep going on things rather than trying to make things perfect. Even if you complain that things are wrong, you can still go, right, it's okay, it's wrong, but that'll do. Right, so address plus equals data width. Otherwise, not Python, address minus equals data width. Right, that should work. Now, of course, I've got to actually implement read line because I haven't yet. So let's go do that. How much time we got left? Got 10 minutes left. Yeah, I'm not going to get this finished in just 10 minutes. No. Int read line. Char star line. Int len. Read line. Call read line for the line we are. Just for input, that'll do. Line points to the line to read. Max length, including terminator and one for success. Failure. Calling us read line is really hard. Here we go. Right. 0 to 4. Sorry, I jumped in and out of that really quickly. Right. So R0 contains the buffer. R1 contains the size of the buffer. But R0 also contains these other flags, which means that it's a 26-bit interface. There is a read line 32, which does the same thing, but without the 26-bit limits. But you have to know which version of the OS you're running on to be able to use it properly, which makes it all very, very tedious. Anyway, let's just get the 26-bit version working, then we'll add the 32-bit version afterwards, because you're pain. Right, so R0 is the line, R1 is the size of the buffer, there we go. Lowest ASCII value to parse, 32. Highest ASCII value to parse is going to be 128. I don't want it doing anything special. And character to echo if bit 30 is set. Well, we don't actually care about that because it's not going to be set. Okay. Kernel os error equals equals. Ooh, no, not equals start if return 0. Right, so that would be the correct implementation on a 26-bit OS, but we want to work on both systems, so we need to know whether it's the 32-bit interface. 32-bit interface is different, and it isn't compatible, which is amusing. I need to remember how to do it, so pass read line 32. There we go. Yeah. You see, you can't just call os read line 32 and then check for the error. Because if you check for the error, then it could have been that the errors returned was, I suppose I could check for why not found as the error, I guess. Yeah. I also need to get back the number of bytes read. I've just realised that. And that's here. It's got out. Oops. It's in R1. And that's actually the same syntax here. You know, I'm not even sure I'm doing this right, but I'm gonna just continue blindly anyway. I also need to get the flags out, don't I? Because it returns the C flag set. That should be a uint 32. Escape is an error as well. I'm just going to assume that an error is not fatal here. That's not right though. RISC OS kitten, not new, RISC OS.h dot new errors. Bad swy. I don't think it's called bad swy, is it? It's just called, no. Is it bad swy or is it naff swy? Oh, either of them are the same. Okay. That'll do. I think that's about right. Somebody can correct me and tell me what the correct syntax is for doing this. I may have just screwed it up, but well, apparently it's wrong anyway. 272. Qualify using implicit custom. Oh, yeah, because that's a const. Since we pass it in as a const, it's, yeah. That's looking kind of good. Memory A 9000. 1, 2, 3, 4, 5. Wrote 1, 2, 3, 4, 5, 9000. Enter just to go to the next line. That's not right. That's not right at all. Okay, let's try again. Oh, yeah, the reason that I read I returned the number of bytes that were read was so that, come on, pointer, stop dancing, and so that we could actually terminate the string. Line bracket read was, because otherwise it'll be terminated by the return and therefore won't be parsable properly. New value, that one. Okay, new value, is it 9004 76 776 10 underscore 90. That seems reasonable. 90 and base 10 comes out as 58. Just move to the next line. Yep. Go backwards. Go backwards some more. What was the other one you can do? Oh, dot to exit. Oh, look at that! It's all working! That's quite cool. That's really quite cute. Right, well, exit out of that. Status. Are we done? Is that all of memory A? I think it is. Completed the implementation of star memory A with interactivity. You can now interact with star memory A, and the interface, we match the original interface from the classic debugger. The order of ASCII and words may be different. Okay. I'm also going to vmanage inc that. I'm going to put that into the same version, same thing, because I don't see any. No, I'll put it in a new one. Increment version to 0.04. And we'll push that, tag it with v0.04. And I won't push it just yet because otherwise it will overload the server. I'll wait until the current build's done. But that means memory A command now implemented. I thought that was going to take way longer than it did. Yeah, that's cool. And it's building 0.04 now. Once that's done, I'll go and push it. And we'll have I'll go and push the tag, and then I'll do that. But I'll take another 10 minutes or so. So I'm going to call it there. We've just passed 3 hours on the stream, so I think that's a fair time to finish. Today we have implemented command syntax. The fix for the command syntax help being untidy. Yes, that was only adding new lines on the end of things, but it was good. Added the error numbers, the error blocks and returns. So we've now got errors coming out of some of the interfaces. We've added CI builds so that we should be able to have builds that happen automatically every time we push things. Which means that if anybody else wants to work on it, they don't necessarily have to have the compiler and stuff. They can just build it on there. And now just implemented star memory A as well, which I think is all pretty good. I had some great stuff and good works from people on the channel. I hope that was interesting. We've got a reasonable way through it. There's a few things still to do. Yeah, 1 or 2 things here. A bug that I've just raised and a few other things. And if anybody wants to raise issues on it, just to say that they'd like things, then please ask. Or if they test out the versions that have been released and they find bugs, please go and raise issues, and we can put them onto the board and make sure that they are addressed. Specifically, if there are bugs that people raise, I will do those as a matter of priority in the next session. I don't know if I'm doing a session next week. I will decide later in the week. It depends on how things are. I really enjoy doing these, so it gives me a bit of a boost on a Sunday. So we'll see. All right. Oh, one other thing is, obviously I'm testing this with Pyromaniac. If anybody wants to try out Pyromaniac on their systems and they haven't already got a copy, just drop me an email and I can send you the details and invite you to the repository. It's dead easy to use. Plus, of course, you can always use the shell.RISC OS online system as well. All right. That's it for today. I hope you have a good afternoon, and I will see you all next time round, maybe, if you're around. Bye.